And for 16, we just have for as limit approaches 1, so limit of x approaches 1 from the left side, f of x does not exist. This is going back to graph since it's an infinite discontinuity, and limit x approaches 1 from the right side, which is f of x, and it's -2. So this limit does not exist, because for a limit to exist, the limit from the left hand side and the right hand side has to be the same. So for limit as x approaches 4, that's limit x approaches 4 from the left side, f of x is 1, and limit of x approaches 4 from the right hand side, f of x is also 1. So this does exist. And for the final one, limit of x approaches 0 from the left hand side, so that's only talking about the right hand, or the going approaches from the left hand side, so f of x. And going to the graph, it approaches infinity here, so this will be just infinity, and this does exist. Okay, for 17, so it says find the value of k and m so the function below is continuous on the interval -infinity and infinity. So let's do the first two equations first. So let me use a different color. So limit x approaches -2, x squared minus k x plus 3, and limit x approaches -2, 2x minus 3. So we plug in -2 for x, so the first one would be is equal to 4 minus k -2 plus 3. And this one is just 7, or -7. And so if we set that up, limit x approaches -2, 4, or got it right, f of x, 4 minus k, or this will be just plus 2k plus 3 is equal to -7 minus 3. Then u minus 4. So 2k equals -14. K has to equal -2. Or no, -7. Sorry, read that wrong in my mind. So I'll put it that here, and then use a different color for m. So m as limit x approaches 3, 2 of x minus 3, as limit x approaches 3, 3 minus 2m. We plug in 3 for x, so this is just 3. And so if we do this, because we can't plug anything in, this will be just 3 minus 2m. And let me move this up. So limit x approaches 3, f of x 3 minus 2m equals 3. So minus 3 minus 3, negative 2m equals 0. 2, 2. So m equals 0. There, that's the answer. For number 18, if you just plug in 0, you should get negative 3 over 1, which is just negative 3. For 19, you kind of want to factor this out, so this will be x, or 3x minus 1 and 3x plus 1, and the bottom would just be the same, 3x minus 1. And you cancel out this and you plug in 1/3, so you get 1 plus 1, and you just get 2. For 20, you have to use the differences of cube to factor this out. So that's a cubed plus b cubed equals a minus b, a squared plus ab plus b squared. Okay, so I'll just move this up a little bit so we have some space. So then this will be x minus 2 and x squared plus 2x plus 4. The bottom will be x minus 2 and x plus 2. So once you cancel this out, you could just substitute 2 in for x. And you should get, for the top, 4 plus 4 plus 4, so just 3 times 4 is 12, over 2 plus 2, which is just 4. So 4, so 12 over 4 is 3. So for 21, if we use direct substitution, so 2 minus 3, that's negative 1, and 6 minus 7, which also negative 1. So the correct answer should be this, because negative 1 is not equal to negative 12, which is g of 2 is negative 12. And the limit x to 2 is equal to negative 1. Okay. For 22, we could just look at the largest degree, and so it should be 7 over 2. For 23, you multiply by the reciprocal, so root 2x plus 5 plus 1 over 5 plus 1. And you guys could just do the math for that, but if you plug everything in, it should be 0. Okay, so for 24, so f of x plus h, so that'd be just 3 x plus h squared minus f of x, so minus 5x plus h. And now you FOIL, then multiply, so you get 3x squared plus 6xh plus 3h squared minus 5x is 5h, 3x squared is 5x. Okay, so you get 6xh plus 3h squared minus 5h. Now you get h over h, 6x is 3h minus 5. And if we plug in 0 for h, that's 6, because the 2h cancels out. 6x plus 3h minus 5, it'd be just 6x minus 5. And move this up here. So, answer is B. And for 25, the x squared, when you root, it just becomes x. So 5 over 1 is just 5. So 26, you want to kind of factor this out. So 2x plus 3, x minus 1. So if you look at x equals negative 5, so we know on the bottom x plus 5 is one of them, and the other one would be just x minus 1. So there's a removable at x equals 1. And so to find if it's an infinity or a negative infinity, just plug in a value smaller and or bigger, like smaller and bigger than negative 5. So if we plug in, well, in this case, either one is going to be negative, so it'll be just B. And for 27, so which of the following is true? So let's look at this. So limit, okay, let me find a place where I could write this. So limit x approaches 3 from the left, h of x is, because we just plug in 3 for x, so that's 9 minus 5, which is 4, and which is equals limit x to the 3 from the right side, 9 minus 6, which is 3. So these do not equal. So the only thing that applies here is 1, because as x approaches 3 from the left side, is 4. So it's 1 only.